everyone and welcome back. We are going to continue on with C puzzles, operators 4, bitwise operators. In this video we're going to go ahead and continue with operators 4.6 where we left off, operators 4.5. Here we have a new puzzle to solve, which is the one right here in this snippet of code here. We have the macro print, we have the bitwise complement x, bitwise OR with x. Again, using the print macro we've defined here above for the main function. Now usually I go ahead and jump into and explaining the actual solution to the puzzle, the way I would solve it. But in this case we're going to switch up a little bit. We're going to go ahead and jump to the code, see what comes out, and try to see if we can explain what's happening with the code and see if that matches what we can figure out in our explanation. So at this point, feel free to pause the video and try to solve this yourselves, and let's jump to the code and see what the output gives us. Right, here again we have our C file opened. We can see here we've added a new line, line 17, that includes the new puzzle here, print, bitwise complement x, bitwise complement OR x here. Let's go ahead and compile this and see what we get out. And once again, we're going to use GCC as our compiler, passing in the -o flag, the name of the executable, as well as the name of the file. Now if we actually run our executable, we can see here at the very end that we have the bitwise complement x, OR with x gives us -1. Let's go ahead and try to explain how we got this -1 out back in the explanation. Alright, welcome back. We are here with operators 4.6 on the explanation. Once again, we have our setup where we have 3 integers, x, y, and z. We've initialized their values to be, let's go ahead here, 1, -1, and 1 respectively, both in decimal and octal format. Decimal being the x and y, z being the octal format. And once again, we're trying to evaluate the line of code being the print macro, or a puzzle here of print, bitwise complement x, bitwise inclusive OR with x, and again, got 2 operators here. We got the complement and the inclusive OR. And we're trying to evaluate which one do we go ahead and execute first in terms of the operator precedence. And we can see that if we review our table that we have previously done in previous videos, we can see that the bitwise complement will have the highest precedence between the 2 operators. Therefore, going from left to right, we're going to go ahead and bind that x value to this operator, this squiggly here. And once again, what this squiggly operator does is it's going to turn every 0 to 1 or 1 to 0. It's going ahead and complement in that sense. And the result of that complementation will then be bit ORed with x itself. So once again, pick the value of 1. And ultimately, the result will then be printed out or called into the print invocation of the macro. So here again we have the print call. Recall that in this scenario we're treating x, the integer, as 32 bits. So once again we can consider x being a whopping 32 bits for a value. Looking at x being a value of 1 will look something like this, where 1 is being set in the lowest significant bit, and the rest of the remaining, the upper 31 bits, are 0 as they are in memory, as the compiler goes ahead and allocates this 4 bytes for this integer. When we go ahead and try to compute the bitwise complement of x, once again we're going to flip 0s to 1s and 1s to 0s. So going back from the previous slide here, we see that the upper 31 bits that were 0 would now turn into 1, and the 1 in the 0th spot will now be complemented to 0. And you can see here that this value here is -2, assuming you have a 2's complement machine, which I do in my laptop here. We can see here that most machines here you would get -2 since most machines nowadays are running 2's complement, unless you're running a previous version of Windows, early 90s or something that you had a 1's complement. But in most cases, we're going to get a value of -2. And so now, once we've computed that, now we're going to bitwise inclusive OR this -2 value with this value of 1, which is again the value of x originally. And if we go ahead and try to do that in our calculator here, let's go ahead and have 1, right? If we use our calculator here and we do bitwise not, we can see that the result was we've complemented all the values here. So once again, get a value of -2. If we go ahead and bitwise this with bitwise OR with 1, which is what we're trying to do in this puzzle, scoot over here, we can see the result will be -1. And looking at our bits, we can see that all the bits will be set. Again, the value will be -1 because of this being a 2's complement machine. So therefore, once again, the value of -1 gets passed into the macro. And going back to the output of this puzzle, we're passing in the stringization of this string, and the result will be printed as -1 as the %d for our print specifier here, again using the string conversion. And the result, as we saw previously, and the output when we ran our code was bitwise complement x, bitwise inclusive OR equals -1 as expected. So again, we jump back here, confirm here that that's the result. And once again, thank you again for watching this video. To watch the previous video, go ahead and click on the bottom left-hand corner. To watch any of the previous puzzle videos, go ahead and click on the playlist in the bottom middle of the screen. And to watch more C puzzle programming content, go ahead and click on the bottom right corner and subscribe to this channel. I'll catch you all in the next video.